now that we know how to implement the gradient descent using PyTorch, let's look at a more interesting example. The example we have been looking so far is unbounded below because of the linear term, so it doesn't make much sense to try to minimize it. Let's look at this new loss function, which I have here, and try to minimize this one. The only thing that we need to change is how we compute the loss. So I redefine compute loss here to match this function. The rest of the steps are more or less the same, except that I'm also keeping track of the trajectory of the gradient descent. So to do that, we create a torch tensor filled with zeros. I'm doing 400 iterations, so that's the variable that takes or keeps track of that. And then we can use torch.zeros to create a vector, or a matrix in this case, or a tensor in general of zeros. Here the dimensions are 3 times 400. So each column is going to represent one point in the trajectory of the gradient descent. So the first two coordinates is going to be filled with W, and the last coordinate keeps track of the loss. So our variable has 2 coordinates. So basically what would happen is that trajectory 0 would be equal to W0, trajectory 1 would be equal to W1, and then trajectory 2 would be equal to loss. Okay, so that's what will happen here. And using slicing operations on torch tensors, which are similar to numpy arrays, you can do it compactly like that. And then the rest you can see is our gradient descent implementation. So we zero out the gradient, we update the loss, and then keep track of these values, and then perform gradient update. So this updates w.grad, and then update w by taking a step using the update.step function. Okay, so this is exactly the same as we had before if you remove these 2 lines. And then at the end we do this operation of detaching the tensor, which detaches the tensors from the computational graph, basically forgets about the gradient update. And then we apply numpy function, so this turns it into a numpy array. So this is PyTorch sort of prescription for turning a torch tensor into a numpy array. And then, so let me try to run this, see if it runs. Yes. And then I'm going to plot the trajectory. You can see it plotted here. And a couple of things to note is, so first the z-axis tracks the loss. So you can see the loss is sort of going down, and then the xy plane basically are showing the trajectory of w. So we are going down until we hit the origin, which is the minimizer of this loss. One of the other things to note is that a trajectory of gradient descent is not necessarily monotonic, so the loss can go up and down, and here there's some sort of jagged area, so it goes up and down like multiple times until we converge. The second point to note is that this function is not convex, and it's like highly sort of non-convex, and still the gradient descent manages to converge to the global minimizer. So let me try to plot. That's like the view in the xy plane, and you can see this is the path taken with the gradient descent in the w plane. And then we can also plot the loss, and you can see it sort of goes down in general, but I mean, early on it just jumps around, goes up and down a lot of times. And the behavior also is affected by the step size. So if you change the step size here, you get different behavior. Okay, so that's how you can visualize the trajectory of gradient descent in this example.